So the problem is about buying a house. $40,000 is the down payment, and you've got 5 years time to get that $40,000. And there's a couple of ways to get it. First, leave this area, go to a different state. You can't afford anything. If you live here, you know how drastically things change over the last decade. Okay, what we need, $40,000. For a down payment, and the time period that you have is 5 years. So somehow you've got to get that amount without robbing a bank. So how much should you deposit today if in 5 years you get that $40,000, say in a bank with some interest? So we have an interest rate of 6.4%. We have the time. Was it quarterly?
Yeah.
Damn it. I never thought you paid attention. I'm glad you are paying attention. That was a joke. How much deposit should they make today at a rate of 6.4% interest, compounded quarterly? So the question naturally becomes, well, what formula to use? We've got two of them. Any thoughts? You should know by now. I'll write straight, you can check. First formula. Second,
First one.
why? You're all good, because it is compounded quarterly. The second case is if you compound continuously. So we want to use the first formula. We know R. What is R? The rate. 6.4%, which would mean in terms of the decimal 0.064. The term is given to us how many years? 5. What is M? 4. Y? Quarterly. Impressive. What is the amount that the couple is looking for in order to go for a down payment? 40,000. So here's a question: is A 40,000 or is P 40,000? A is 40,000. just put in all the values. How do we find this answer? Well, 40,000 would equal to 0.064 divided by 4.016 plus 1.016 raised to 20. Just to refresh your memory, what type of equation are we dealing with? Exponential. Very good. Exponential equation. In this problem, we don't have to take logarithms because number, all we have to do is divide. So divide both sides. By that, and even before you start the problem, you've got to know the answer P, should it be less than 40,000 or should it be greater than 40,000? Less than. It has to be less than 40,000 because you start with a smaller amount, you are trying to grow it over the years so it reaches 40,000. So what is that answer? Ben? $29,000. How much? $19. 418. 119. Good. So if you spend if you put in $29,119, I believe this is an approximation, it is not going to result in that number exactly. You'd end up getting $40,000 in 5 years. So what is this? Yes. Part B wants to know what is the interest earned? Hey. How much?
$10,881.
$10,881. Very good. How to do that?
Subtract 29,000 from 40,000.
So yeah. 40,000. Go ahead. Sorry.
No, I was done.
Go ahead.
I was done.
You were done. Okay. $40,000 is what they were looking for. Initially, they put in $29,119. So 29,119 initial amount. After 5 years, you get 40,000. In the compound interest formula, that final amount includes the initial amount and the interest. So the difference would be the interest part. Which is $10,881. Good. We'll keep that. Same equation, same logic. Not even going to write the question yet. Parts A and B tell us that you've got to put in $29,119 today at this point in time. Assuming 6.4 interest. Good luck getting that interest. There is no way. It's probably maximum of 1.5%. As of today, they've got only 20,000 to put in that account. Even before you start the program, do you believe in 5 years they would get to that $40,000 if they need? Nathan?
No.
Why not?
Because we found that to get to 40,000, you need 29,000.
Very good. To get to 40,000, you've got to start with $29,190. Definitely, I'm not going to make it. So formula remains the same, but this time, what are we trying to find? Are we trying to find A or are we trying to find P? We're trying to find A. So A would equal to P times 1.016. Nothing else changes, so M times T, which is 20. Put in $20,000. If this answer exceeds $29,000, my life would be meaningless. So it better be less than that.
$27,472.
27,000, how much?
472.
472, approximately, right? Might be exact.